Hello my dear students of class 10. Today we will be discussing about coordinate or dative bonding. So coordinate or dative bonding is a special type of covalent bond. We have studied our covalent bonding. In covalent bonding we have this one electron coming from one atom and another electron coming from another atom to form the bond. But in case of coordinate bonding, here the shared pair of electron will be coming from only one of the combining atom. Suppose you have a molecule say A and B. Okay? So if A possesses say a lone pair of electron, then both the electron of A will be involved in bond formation with B. That means both the electrons from A will be shared in bond formation between A and B. Such type of bonding is known as what? Coordinate or dative bonding. Here, since this A is donating its lone pair in the bond formation, this A is known as donor atom and B is the acceptor atom. For example, we have seen about ammonia. In case of ammonia, we have nitrogen containing 5 electrons in the valence. Now these 5 electrons, out of 5 electrons, these 3 are involved in covalent bond formation because one electron from nitrogen and one electron from hydrogen has been shared. Therefore, these 3 are now covalent bonds. Now this lone pair of electron, whenever it is freely available over nitrogen. Now whenever you have a proton, say H plus ion, okay, H plus ion, and this H plus ion is deficient in electron, that means it doesn't have any electron. Now whenever there is formation of ammonium ion, then this lone pair over nitrogen will be donated to H plus ion, and this bond is known as what? Coordinate or dative bond. Okay. Similarly, you have a water molecule. Now, whenever water molecule and say is present in acidic medium, then what will happen? They will combine to give you H3O plus ion. This is hydronium ion. How this hydronium ion is formed? Oxygen is present. You have 2 covalent bonds. Now, oxygen has 2 lone pairs. Now, whenever this H plus ion comes and gets bonded with oxygen, then you can see that the lone pair of electron over oxygen is being donated in the bond formation between oxygen and hydrogen, and this is again the coordinate bond or dative bond. Similarly, you have other molecule. So let's discuss about that. Okay? So I hope now you understand what is the difference between covalent bond and coordinate bond. Let me tell you once again. In covalent bond, equal one electron from one of the combining atom and one electron from another atom, they come and they mutually share to form covalent bond. That means equal contribution. One from one atom, another from another combining atom. That gives you covalent bond. But in case of dative bonding, you can see that whenever there are lone pairs present, then this lone pair is used in the bond formation between the combining atom, and both the electron has to come from one of the combining atom. Now let's discuss about the electron structure of different compounds. And here we have nitric acid. What we have? We have nitric acid. HNO3. So this is the formula for nitric acid. Now in this case, nitrogen, as you know, it has how many bonds? It has 5 electrons in its valence. Now one of this electron will be shared with oxygen. Okay, so here you have oxygen. Now oxygen has how many electrons in the valence? 6 electrons in the valence. Okay, and this oxygen now will form a covalent bond with what? This hydrogen. This is a covalent bond, and here also is a covalent bond. So you can count now for oxygen 1, 2, 3, 4, 5, 6, 7, 8. So its octet is fulfilled. Similarly for this hydrogen, its duplet is complete. Now you can see that nitrogen has 2 lone pairs. Now these 2 lone pairs will be involved in bond formation with what? With oxygen. You have 3 oxygens. So out of that, one has been involved in covalent bond formation. Another oxygen atom, say it has again how many electrons in the valence? It has 6 electrons in the valence. Yes or no? So now this 6 electrons will be, out of 6 electrons, 2 of it will be involved in bond formation. Say 1 electron, single bond. This electron and this electron will be forming double bonds. Yes or no? Now we are left with one more oxygen atom. That oxygen too has how many electrons in the valence? It has 6 electrons in the valence. Now these 2 electrons over nitrogen will be involved in bond formation. Which bond formation? Here you can see the arrow. That means it will be involved in which bond formation? Coordinate or dative bond formation. So now here let's count the number of electrons. For this oxygen, 6 was already present. Now 2 of it, of the nitrogen atom, has been involved in bond formation, covalent bond formation. There are 6 plus 2 is 8. Now for this nitrogen, we can count it 1, 2, 3, 4, 5, 6, 7, 8. Its octet is also fulfilled. And here for this oxygen, 1, 2, 3, 4, 5, 6, 7, 8. Therefore, now the atoms in HNO3, now they have acquired this noble gas configuration. Hydrogen, duplet, other atoms, they have acquired which configuration? They have acquired octet configuration. As a result, if you write it showing the bond, then you will be having this structure where you have oxygen, and this is the dative bond, and these bonds are all what? Covalent bonds. This too is covalent bond. Okay, so this is the structure of HNO3. Now let's discuss the oxy acids of chlorine. Now chlorine can form 4 oxy acids. Now we are going to discuss about the electrode structure of oxy acids of chlorine. So oxy acids of chlorine. First one we have is HClO. Number 2 we have is HClO2. Number 3 HClO3, and number 4 we have is HClO4. Now the name of this oxy acid of chlorine is hypohalous. This is hypochlorous acid. This is hypochlorous acid. You have to remember the name. Hypochlorous acid. This is chlorous acid. Okay, this is chlorous acid. Now this is chloric acid. Chloric acid, and this is perchloric acid. So we have 4 oxy acids of chlorine. Now we are going to discuss about the electrode structure of each of these acids. So first we will be discussing about hypochlorous acid. In case of hypochlorous acid, we have HClO. So we have chlorine. You know chlorine has 7 electrons in the valence shell, out of which an oxygen has 6 electrons in the valence shell, and hydrogen has 1 electron in the valence. So here you can see that these two will be involved in bond formation with hydrogen, covalent bond formation, and these two will be involved in again covalent bond formation. So we will be getting the structure of hypochlorous acid as HOCl. Here we can see that both the bonds that are formed between oxygen and hydrogen is a covalent bond, and the bond formed between oxygen and chlorine atom here is also covalent bond. Okay, so both the bonds in case of hypochlorous acid is what? It is covalent bond. Now its duplet configuration is obtained. Now here 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. Its octet is fulfilled, and for this chlorine, its again octet is fulfilled. Now let's discuss about chlorous acid, that is HClO2. Here again we have oxygen with 6 electrons in the valence shell. Hydrogen has 1 electron in the valence shell. Chlorine has 7 electrons in the valence shell. And here you have 2 oxygen. So 1 oxygen is present here with 6 electrons in the valence shell. So these two again will be involved in bond formation, covalent bond formation. These two will be again involved in covalent bond formation as in case of hypochlorous acid. Now here, with this you saw that each of its Vowel gas configuration is fulfilled. Now this oxygen has 6 electrons in the valence shell. It needs 2 more electrons to be octet. Therefore, both the electrons of chlorine will be used in bond formation between chlorine and oxygen. And the bond that is formed here is what? This is coordinate bond. Coordinate bond. So the structure of this molecule, you have it as HOCl, and here you have Dative bond. This is Dative bond, and these two are what? Covalent bond. Okay, so this is the Electrode structure of chlorous acid. Now let's discuss about chloric acid. In chloric acid, you have 3 oxygen atoms. Chloric acid. Now in case of chloric acid, you have 3 oxygen atoms. Now from this structure itself, let's come to the structure of chloric acid. Okay, so here you can see that you have 2 oxygens. 1 more extra oxygen is present in case of chloric acid. So this oxygen again will have how many electrons? 1, 2, 3, 4, 5, 6. This one of 6. The other rest of the bonding is same. Now these 6 electrons are present. These 2 electrons, which is present as lone pair over chlorine, now will be used in bond formation with this oxygen molecule. And this results in the formation of Dative bond. So here what we have is we have 1 more Dative bond in case of chloric acid. Here you have 2 Dative bond. This is a Dative bond or coordinate bond. So in case of chloric acid, you have 2 Dative bond. Now let's discuss about the structure of perchloric acid. Perchloric acid. Now in case of perchloric acid, how many oxygen atoms are present? 4. So from the structure of chloric acid itself, we can come to the structure of perchloric acid. Now, this is the structure of chloric acid. Now, in case of perchloric acid, you have one more oxygen, and you can see that this lone pair over chlorine is available. Now, this lone pair over chlorine will be used in the bond formation with this oxygen atom. Now, here again, what results? This type of bond is resulted. Here again, you have a dative bond. This is a dative bond. Now, you can check that. Now, once this lone pair is involved in bond formation with this oxygen, then its octet is fulfilled. Other atoms' octet is fulfilled as well as hydrogen's duplet is fulfilled. So we get, in case of perchloric acid, we have how many dative bonds? In case of perchloric acid, we have 3 dative bonds, which is formed with 3 oxygen atoms. Okay, so you will be asked to draw the structure of oxy acids of chlorine. So you need to practice it properly. This is very simple. If you just remember the sequence, the first one, hypochlorous acid, it did not have any dative bond. Then we came to chlorous acid, it had one dative bond or coordinate bond. Then we discussed about chloric acid, it had 2 dative bond. And in case of perchloric acid, we see that it has 3 dative bonds. So this is how you draw the electrode structure of certain molecules, and this you need to practice it properly.